Hi everyone, welcome to Lecture 5B on Basic Inorganic Chemistry. My name is Dr. Teresa Chimambam. For today's lecture, we will cover structural formula and formula weight. So what is structural formula? In the previous lecture, we discussed about molecular formula. So now we are talking about structural formula. So what is this structural formula? Structural formula shows us how atoms are bonded to each other in a molecule or ion. It shows a three-dimensional arrangement of the atoms in space. So let's have a look at some examples. Ethane has molecular formula C2H6. For the structural formula, you simply need to draw the structure in such a way that the bonding between the elements will be shown. So here I have drawn out the structural formula. You can see I have shown the bonding between all the elements in this particular compound. So there is a single bond between each carbon and hydrogen, as you can see here. And I still have the same number of elements I have here. I still have it on the structural formula. The only difference is that I have shown the bonding between the different elements. So I have C2 here, I have two carbon atoms here, I have H6 here, and I still have 6 hydrogen atoms here. So to write the condensed structural formula, you simply start with the first CH3, you write CH3. You don't need to show bonding when you are writing the condensed structural formula. So CH3 and another CH3. So this condensed structural formula for ethane is CH3, CH3, and the molecular formula is C2H6. So let's have a look on this one. So this is ethanol. The molecular formula for ethanol is C2H6O. The structural formula, like I said earlier, you need to draw it in such a way that the bonding between the elements will be shown. And you must not increase or decrease the number of elements in the molecular formula. It must exactly be the same number of elements that is shown on the molecular formula. So here you can see there is a single bond between each carbon and hydrogen, as you can see here. And here there is a single bond also between each carbon and oxygen, and there is a single bond between each oxygen and hydrogen. So the same number of hydrogen I have here, the same I have on the structural formula as well. The same thing is applicable to the carbon. I have two in the molecular formula and I have two in the structural formula. I have one oxygen in the molecular formula and I still have one in the structural formula. The only thing I have done is that I have shown the bonding between the elements in the compound. So to write the condensed structural formula, I start with this CH3. The next one is CH2 and then OH. Remember, when you are writing the condensed structural formula, you don't need to include the bonds. So the next one is propane. The molecular formula for propane is C3H8, and this is the structural formula. So it shows there is a single bond between each carbon and hydrogen. And to write the condensed structural formula, I start with this part, CH3, the middle one is CH2, and then this last part is CH3. So I don't need to include the bonding when I'm writing the condensed structural formula. So this is how to write structural formula from molecular formula and also how to write condensed structural formula. For example, if you are asked to write the condensed structural formula for this structure. So to write the condensed structural formula, we start from the beginning. We have CH3, you write CH3, You don't need to write the bonds. The next one is CH2, we write CH2. The next one is CH2, we write another CH2. The next one is CH2, we write another CH2. And the last one is CH3, we write CH3. So this is now the condensed structural formula. So you can see I follow the way the structure is run to write the condensed structural formula, and I have not included the bonds. So the next thing is, what is its molecular formula? So the molecular formula is simply obtained by counting the number of elements. So carbon is 1, 2, 3, 4, 5. Then it will be C5. Then you count hydrogen 5 here, 10, 11, 12. So C5H12. And the name of this compound is pentane. So now we look at ball and stick model. The ball and stick model shows the three-dimensional arrangement of atoms, as well as how the bonds between them are connected. So ball and stick model shows us the three-dimensional arrangement of atoms and also shows us how the bonds between them are connected. So water, for example, has a ball and stick model that looks like this, and methane has a ball and stick model that looks like this. The space filling model for water molecule is shown here, and the space filling model for methane is shown here. So this is how ball and stick model looks like. Each compound has its own ball and stick model. Now we look at formula weight. What is a formula weight? Right. The formula weight is the sum of all the atomic weights of elements in a compound. So if you are asked to calculate the formula weight for H2SO4, you need to add all the atomic weights of the different elements that are present in this compound. So you also need to take into account the subscripts as well. So for H2SO4, we start by adding up all the atomic weights of the different elements. So hydrogen has atomic weight of 1, so we multiply by 2 because of these 2 here, plus 32 for sulfur, plus 16 for oxygen. We multiply by 4 because there are 4 oxygen atoms in the compound. So when we add up all, we get that formula weight for H2SO4 is 98 gram per mole. Gram per mole is the unit for formula weight. So for copper 2 sulfate, we do the same thing. So we start with copper, which has atomic weight of 64, plus 32 for sulfur, plus 16 times 4 because we have 4 oxygen atoms. So that gives the formula weight for copper is 160 gram per mole. So to calculate the formula weight for glucose, we do the same thing. So 12 multiplied by 6, we have 6 carbon atoms, and the atomic weight of carbon is 12, plus 1 multiplied by 12, we have 12 hydrogen atoms, plus 16 multiplied by 6, because we have 6 oxygen atoms. So then the formula weight for glucose is 180 gram per mole. So this is how to calculate the formula weight. You simply need to add up all the atomic weights of the different elements, and you take into account the subscripts as well. Right, so this is where I'm gonna end this video. Please like this video and subscribe, and I will see you in the next lecture.